Okay, good call. All right. So I wanted to uh, talk a little bit about data today. I'm going to try to give the story in two parts. And the first part is conceptually, what are we trying to achieve? Um, to some extent, if Condor or HTCSS didn't care about data and said, well, you have a shared file system, go at it. It would make our life so much easier. Um, but I want to communicate the why of why we believe thinking about managing data is so important, and communicate a little bit about the how. What is the mental model that we are trying to describe? So I'm going to use a little bit building on the path example, talk a little bit about the OS pool. I'm going to try really hard not to step on Frank's feet, who's talking about the OSDF next, but I am going to a little, so with apologies. So in order for us to be able to share resources, in fact, even forget about sharing resources, in order for us to provide throughput to users, dedicated or shared, one of the things that we have to do within the ecosystem is manage our finite resources. And this is something that's really easy for us to think about when we talk cores. And in fact, looking back at Doug's talk, he said, oh yeah, you manage things like CPU and disk and memory. And we always put CPU first because usually we can count those on our hands, or at least we have been able to traditionally. So we can count them. We can measure them. The OS says you are using 3 CPUs or 4 cores or 100% of your allocated processes, and we understand how to enforce them. It used to be that all we could do was, if somebody used too much, we could hit them on the head and say bad, preempt them. And now we have fancy things like C groups and whatnot. But for any of these finite resources, we have to think about how we model the capacity. Is it counting cores? Jobs need a way to describe the resource needs, and Condor needs some sort of enforcement or mechanisms of policy. The mechanism might be, we can hit you on the head, and the policy might be, if you go over your requested amount for over 5 minutes, and then boom. And this is, again, very natural for some resources. And one thing that we really tend to forget as a finite resource, especially despite the network people screaming otherwise, is, for example, data movement. So if you think about it, storage services have a finite capacity for moving files in parallel. Particularly if you think of spinning disks, your spinning disk could probably only move maybe 10 files in parallel at a time. Networks have a finite capacity, believe it or not. And then even beyond moving, we can think of resources in terms of space, and whether it's on the sandbox of the EP, or if it's for checkpoints or output data on the access point. So these are finite resources. Therefore, like I said at the beginning, if we don't manage them, somebody's going to have a ruined day. So what I'm hoping that I can convince folks is, you want Condor to manage your data in the same way that you want Condor to watch your CPU usage. And if you don't, you end up with a mess. If Condor doesn't have the ability to watch your data, you end up with a mess. So if I can convince you, managing data within Condor, letting the access point know what's happening, letting the framework sitting around, say your wrapper job, know what's happening, I can convince you that's important. What deal is Condor trying to make with me? So, Christina, really loved your making pizza example. So if you tell Condor, the ingredients to your job, if you give Condor the executable and let it know what the output should be, uh, it can do a good number of services for you. So Maroon touched on the easy, obvious one. It can trigger the data, right? So it can move, yes, 90 million files from point A to point B. It can also, carefully use the word trigger here. So Condor itself may not necessarily have to be the one doing the movement. It can just be managing it. It can come in from a third party. It can, we have this wonderful plugin mechanism that I think is just criminally underused of different ways you can fit Condor and let it know about your data ecosystem. NRAO's talk, for those of you who missed it yesterday, was a great example of people thinking of this. One aspect that's really important about data movement is everybody hates the 8-day long job that gets lost on day 7.5 because the shared file system decided to take a short nap. So if you tell us the ingredients and the executable, we know that in our mental model of the job, it's not going to die because the shared file system took a nap, because the network went away for 30 seconds, because Luster restarted, whatever it might be. So part of our guarantees is that if you use this mental model of your job, then you're not going to see any sort of shared file system failure mid-job. Again, 90 million files sounds big, but I'm not entirely sure that's even the most important things. I think maybe even items 2 and 3 here are the more important ones. If data movement failure occurs, Condor can give a policy of what to do next. We have, again, policies and mechanisms. We can retry, we can present it back to the users, we can go through a list of items based on various execodes. You have that ability to pull out the thing that was buried maybe inside the wrapper script and let Condor execute some sort of policies. And again, I think this is something that's criminally underdeveloped, and we're always looking for ideas of what sort of policies or what sort of mechanisms people would like to express. And then finally, if it manages to do data movement, going back to the idea of sharing, we can avoid overscheduling and more effectively use our resources. So I felt bad without giving at least one Condor submit file in my talk. I wanted to point out the different parts that you can see, and to point out, again, Condor might manage the transfer, and it can do it without actually doing the transfer itself. So for here, what I have in blue, this is examples of where the access point actually moves the data to and from, in this case, to and from the execution point. So Condor is doing this. This is a protocol that we call Cedar, and we can tell you why it's wonderful and encrypted and integrity checked and all those great things. Or you can give it a URL, and it can go off and manage the data here in purple to or from a third-party service. So the intent here is even if Condor is orchestrating things, it doesn't need to be the only player in the ecosystem. It can interact with whether it's Tom talking about Google or S3 or just your favorite file server. Again, going back to policies, here's a couple example ones that we can do. File not found. We can label that as fail error, a fatal error, and wait for the user to come back and say what to do. On the other side, if it's a transient error on the stage end, we can say, hey, retry that up to 5 times, because maybe if the server had a network blip, we think it might be back in 10 minutes. We can avoid problematic sites, however sites might be defined. Or we can, for example, tell the system that our workflow should never have an standard output file more than 1 gigabyte. And if something goes awry, instead of trying to bring back the 1 terabyte standard output file, pause, because certainly everything I know about my workflow is under 1 gigabyte. And again, if you don't tell us this, we can't help you. In terms of management and avoiding overscheduling, this is something that Condor is maybe the most mature, and we've been doing this for the longest time. This particularly worked very well when everything was a disk. Some of this has gotten a little more fuzzy in the last couple of years, when not everything looks like a disk or hard drive. So we have all sorts of complex mechanisms. We maintain a queue. We have a limit on concurrency. We monitor this and that. We have a magical algorithm that says up the concurrency, down the concurrency. This IO is too high. This IO is too, whatever the fancy algorithm of the day is, which is different than the fancy algorithm of last week, which is different from the machine learning algorithm of tomorrow. The point is, we have we have visibility into this, and we can try, or at least work to schedule things depending on how clever we are at scheduling or unclever we are at scheduling. Okay, here we go. One place that's not very mature right now in Condor, especially because it's going to come out next week, sometime soon, is a first stab at actual sandbox management. So we have always gotten excited and talking about data movement, concurrency, and then have done a really lousy job managing storage. So we're really hoping to start fixing that. And one teeny tiny little piece of this is for particularly those running as a batch system, Condor will be able to have much better enforcement mechanisms on the execution point sandbox. So at the technical level, we're actually going to start, a sysadmin can hand over a block device. So they can say, here's a blank NVMe device, or here's your blank hard drive. And Condor will see an incoming job, say, please give me 10 gigabytes. And then actually carve out a small volume from that, put a 10 gigabyte or 10 gigabyte plus file system on top of that, and have the job actually run just within that file system. And here, again, it allows us to monitor instead of having to crawl through your 2 billion files every 10 or 20 minutes and cause all sorts of load on itself. Monitoring resource usage becomes extremely cheap. We just ask the file system, how much did you use? And it provides us an enforcement mechanism. Basically, beyond a little buffer space, if you ask for 10 gigabytes and you attempt to write a 100 gigabyte output file, we're going to detect that, trigger the enforcement, and maybe decide, oh, we're going to start preempting your job, or whatever it might be. So I'm hoping that this, for particular our site batch systems, is going to be the end of the, oh, user so-and-so had a runaway script that he submitted or that she submitted, and now everybody else's jobs are crashing because every place they're landing, they're getting out of this space. So again, this is something that's been a itch we've wanted to scratch for quite some time, and happy to see it. I want to give a few examples from the Open Science Pool. We did a wonderful job introducing those in Science Pool. I think I counted so far 3 times today. The one way I like to point out is that this is a pool where resources are donated, and we try to turn them into effective capacity. Whether they think of them as opportunistic or dedicated or whatever it might be, the site's in charge. And it's heavily distributed. So I think it's embedded within the Open Science Compute Federation and all the dots of the Compute Federation here on the map. So particularly, one thing that I think users really enjoy about the Open Science Pool is it gives a perception of one big cluster. Unfortunately, I think one of the things that users about 2 weeks later really hate is the fact that it gives a perception of one big cluster. Because in fact, it's not. Each of these execution points might be an drastically different site, and I'm fairly sure that the connectivity in some cases between access point and execution point feels like it spans about 3 different orders of magnitude. So if you have a job that's really data intensive and you need that 100 gigabit connection, and you land at the site that's doing a wonderful amount of resources on 100 megabits, uh, you're going to be in trouble if you don't tell Condor about your data movements. In fact, I think it's almost guaranteed if you want to bring in a terabyte of of, uh, of input and you don't tell Condor about it, I guarantee you somehow a dial-up connection will appear with an execution point on it, because that's how life works. Okay, so the OS pool itself for data movement, it pairs really nicely with the Open Science Data Federation, which our next speaker is going to cover. The short version of that is that this provides the OS pool with a file access capability. People can put files into an origin and perhaps more scalably or perhaps better manage access those files from the execution point. So a good example of this is LIGO has their own origin with all the proprietary data. But maybe a better example of this is at the OSG Connect access points, there are actually a dedicated origin that from the same environment within the AP, somebody can put files in the origin and then say, Condor, please pull this through or push it back for output through the OSDF. Whether they gain scale, whether they gain the ability to reuse resources, whether they get better management, there's actually a number of different reasons that they might want to pull it or push it to the OSDF. So what capabilities do we offer to people? Users can move data to or from the access point using Condor's built-in concurrency limits. That's all the direct Cedar protocol we talked about before. They can use it to or from a local cache. And the cache is actually really useful in that it provides a nice throttling point. Again, when we have a site with a limited amount of resources, we like the idea of a throttle. We like the idea of circuit breakers. Your house is much better for having circuit breakers than not. And I, of course, can mention that anytime we use the same Condor HTCS technology, you get all the other capabilities for free. So if somebody comes in and they say, well, all that OSDF stuff is great, but I really just put all my stuff in S3, fine. That's, of course, a feature with Condor. So one thing that I like to point out that we skip in nearly every presentation where we talk about data is the fact that the problem of moving files that we get excited about, talking our wonderful algorithms and caches and access patterns and scalability between the access point and the execution point, that's wonderful. But if you're the user, that is only half the battle. Because no user starts with their data at the access point, 0. Everybody has their user or data somewhere at home, whatever home might be for them. It might be their laptop. It might be their institutional file system that has 10 petabytes. And here to here is actually a fairly complicated process. And we tend to forget it. And I think this really is exemplified by the fact that in Condor, if you go read our lovely 1,000-page manual, will basically give you one option. It says, if you really want to move from here to here, there's a Condor transfer data tool. Is there any retries? No, you get a retry. Is there any workflows? No, you get to write the workflow. So right now for the OS pool, this is just kind of our hodgepodge of stuff. We say, oh, if you fit with SCP, great SCP. Rsync's nice. Here's a Globus endpoint. It's a hodgepodge. We haven't really tackled this problem. But I wanted to point out it exists. So what comes next? Obviously, this is something that we're starting to think about, and like I said, I think it's a little bit embarrassing that we haven't more heavily tackled this. Condor excels at moving data to jobs. We have all these wonderful mechanisms, and we don't offer any of that if you want to move your data to an access point from your home. However, we have with some high throughput phenotypers over the last year and a half been tinkering with this. So we actually do have a small tool that helps generate a DAG with policies, with retries, that allows you to synchronize directories between two locations. So the big question, of course, is can we do this on the fly if a user is pulling in from their laptop? And as my other hand to talk, one thing that we still do surprisingly poorly on is storage management. We don't track how much storage we're using for users. If we have a bunch of jobs that need to have 5 terabytes of output and the user has 5 gigabytes of free space in their home directory, we're going to launch those jobs. We're going to run all those hours. We're going to try to pull things back, and everything's going to crash and burn. So one thing that we've always held is that we should actually set aside and think about the managed space. Anytime we write files, it should go into managed space. Each managed space needs to have an owner, and we have to have some idea of what we're going to do and reclaim or have a lifetime on that. What sort of policies are associated with that space? We haven't gotten quite as far as this one, where I actually have a GitHub repo showing you what you think, but we are really happy to share that NSF has funded a project around the fundamental concept that storage must be managed. And in fact, we just learned about this on Friday. So I'm just like my other talk, I think this is a stay tuned for 2023. So again, take home message. Your data movement is a resource. You want to manage it. And Condor has a fairly compelling set of offerings if you give it over to Condor, let Condor manage it. OS Pool is a great example of all these things in action. And we're going to continue to work and try to improve what you can do on the OS Pool and what sort of tools we can bring to the job. Condor can help you better use that shared resource. It can manage policies. And so forget the 90 million files, but what happens when 9,000 of those fail? You can have policies. And we have a lot of work left undone. We have to do storage management and certainly file transfers inside and outside of the ecosystem is a place that we really eyed as something that we need to work on. Thanks.
All right. Thank you, Brian.
Thank you for questions.